Do you enjoy the conference today? Yeah? Nice. Me too. Actually, tomorrow I'm free. This is my last presentation, so you won't see me tomorrow. Just walking around, sitting in the audience. Today, indeed, last presentation, I am between you and the drinks. So I'm going to keep it as short as possible. And I'm going to talk about a few things, the thing stack, our product, the peering, and the roadmap. So what we're going to do in the coming year. Yeah, and finally also about upgrading the community network to V3. That's one of the most frequently asked questions that I get. So the thing stack. This is the architecture, as you all know. This is what we spend most of the time on as a company to build this. As we presented also in the keynote, most of this is open source. And that's the thing stack on the left-hand side. And then the things enterprise stack is our commercial solution on the right. And we often get the question, so what's the difference between the two? Well, the key differences are that first, the thing stack is feature complete. It supports all LoRaWAN versions, all regions, all modes. It allows you to get your application data in various ways. You can use different APIs. We have MAC layer settings per device, and that means that you can set per device what the LoRaWAN versions are, what the region is, how it should behave. You can set payload formats per device, so you can run everything side by side. You can migrate your old devices, and you can combine that with your new devices in the same network. And it's packet broker enabled, and I'll get to that in a bit. The Things Enterprise stack is built upon the Things stack, so it's the core is the same, and we add around 20 to 30% extra on top of the open source solution. Most important things are that it's multi-tenant, and that means that it's in one environment we can separate tenants, and tenants for us are typically customers. And that means that we have, in our cloud-hosted shared infrastructure, we can combine multiple accounts and we can isolate them in different namespaces. So if you're using the Things Network, community network today, you have your user accounts, your gateways, your application IDs, and they are in one big namespace. And that's also how we continue with the community network. But in cloud-hosted and in the Things Enterprise stack, we can separate these. And this is useful for us because we can separate customers, and you can have a customer with a user account, John, in one tenant, and that doesn't collide with the same user ID in another tenant. But also we have customers that are using this to separate their production, staging, and development environment, for example, or that they resell. Multi-instance means that we can replicate services, so we can scale better. We support device claiming. I'll get to that also in a bit. We have HSM support for the joint server. So our global joint server obviously doesn't store all the root keys in a MySQL database, but instead uses a hardware secure module. And we have that built into our proprietary joint server. And finally, we have integrations with IoT platforms, single sign-on, and billing. So that's the difference, but nothing really related to LoRaWAN, because everything LoRaWAN related, we want to make open source and contribute to the open source community. How to get it? If you are a developer, you can go to GitHub, you can grab the sources, you can compile everything yourself, you can pull Docker images, you can install via package managers, and basically you can figure it out yourself. We have documentation, we have the forum, we have our public Slack accounts, and we have a lot of people actually using this stack and set up a private network using our open source distribution. Things Enterprise Stack is a commercial offering. We have 4 different distributions, cloud hosted, which is operated by us, shared infrastructure. We have dedicated cloud hosted, and then we have a dedicated infrastructure, dedicated cloud infrastructure for you as a customer. We have our cloud marketplace launchers, and we launched one already with AWS Marketplace. So that's if you go to the marketplace, you can find our listing, you can click launch, and you launch our enterprise stack in your own AWS account. And all the billing goes via AWS. And finally, we have self-hosted. So if you have your own infrastructure, we can give you all the binaries and the licenses to do that. And obviously, we have commercial support here. So it's not going to be a sales pitch, but these are the differences between our distributions. So cloud-hosted, we've been onboarding our existing customers for evaluation in the past few months on our new cloud-hosted infrastructure. And it looks like this. You have your network name, for example, in EU on our TTI cloud. But we have multiple of these deployments. So we have our dedicated joint server. We also already have an infrastructure in North America deployed. And we are extending that to Asia and Australia. And when we're done with that, we repeat all over again. And we start deploying more clusters. So that's how we deploy our commercial. And it looks very similar to how we deploy TTN, because that's also in different regions around the world. You can also set up, we also have a dedicated cloud hosted where you can actually run your own domain name in your own environment, and you can start reselling this network solutions to your customers. That's also a possibility. So what we're going to do in the coming year, we are working on LoRaWAN 104 support. So Alper earlier today from the technical committee of the LoRa Alliance presented the new LoRaWAN specification. So we're currently working on that. We're supporting LoRa over satellite that Nicola also mentioned here earlier on stage. 2.4 gigahertz support is also coming. We actually already have it. We are launching our cloud hosted with SLA in the next quarter. We're going to work on a solution for firmware updates. We have been working on that already for a long time, for a few years. And there's still a big gap between the technical solution for device makers and for cloud providers, or for us as a network. And so we are closing the gap because we are going to work on a reference implementation for device makers to make firmware updates easier. And that means that we are going to build a reference implementation for a manifest. So how do you package your firmware? How do you send an incremental update? How do you verify the update? Things like that. Also, we're going to do a QR code scanning app. So we talked about QR codes before in the keynote. And we're going to make that really easy with an app in the App Store to scan a QR code. And that automatically brings you to an onboarding procedure to register your devices. And we're going to work on a repository, get to that in a bit, and the cloud platform integrations. So the repository, we have users and customers that ask us these questions. How many gateways do I need? What will the link quality be? What's the battery life of my devices? How much downlink capacity do I have? And where should I place my gateways? And these are really tough questions in LoRaWAN because it's really hard to estimate this. Because there are way too many moving parts. There are different gateways, indoor-outdoor placement, different antennas, different RF performances in different areas. But if you buy a washing machine, for example, it's really easy. You just look at the energy label and you know how much energy this washing machine is going to cost. So this is something that we should do in LoRaWAN as well, and we should make it this easy. And so what we're going to do with the device repository is to have an open source collaborative repository. So it's open source on GitHub, where device makers and testers and test houses can provide empirical assessments of how devices perform in the field under different conditions. So let's say, for example, you have a parking sensor, and this parking sensor is sending data in spreading factor 7 for half a year. What does that mean for battery life? And what does that mean compared to SF12? And if we know that, and if we have all these profiles based on real-world data, we can actually map that to how the device population is performing in your network. And we can tell you what the battery life of your devices is going to be. And also, we can give recommendations of saying, for example, if you have a gateway here that increases data rate, that means that these devices are going to have longer battery life. So this is not something that we are going to test ourselves, but we're going to create an environment where device makers and validators can contribute their data on devices. And with the actual network metadata that we gather, we can map this together and we can give this insight. So security. Last year we launched the secure elements, but security in LoRaWAN is multiple things. It's secure boot. That means that when the device wakes up, it should check whether the firmware is actually signed by the device maker. Also, when a new firmware comes in, you have to check whether the firmware is from the device maker and not from somebody in the middle. And then there are two specific LoRaWAN things. So storing the root keys and performing LoRaWAN cryptographic operations. And if you forget one of these four things, then actually still your security is pretty much broken. And today, in LoRaWAN, without proper security measures in place, there is a group trust between device makers, contract manufacturers, distributors, networks, applications, IoT platforms, and device owners, because they all have to play well together to keep the entire LoRaWAN deployment secure. So if you design a solution that decouples this, you have to think about all these different actors and see what they need and still make it usable. And also, so decoupling the trust relation, and second, also it has to work at scale. Security solutions shouldn't be too costly, shouldn't be too big, shouldn't cost too much power, and it should allow for transfer of ownership. Because if you have devices here in this building, for example, and if you sell the building, the new owner wants to have access to this data as well. So the secure element helps with that. And last year when we announced this, we got a lot of feedback from the LoRaWAN community. Positive, a lot of positive, but also quite some negative comments because people thought that we were building a lock-in. And so I'm very happy that this morning we could announce that there are more secure element vendors that are joining in. So you have a choice, as well as there will be multiple joint servers. And we will allow for offloading your security keys from our joint server to your own joint server if you want that. You're on your own, on security-wise, but we support extracting the root keys of your secure elements if you really want that. So how does device claiming work? What we did between our joint server and the secure element vendor is to exchange master keys with which we can derive session keys for each device. And to make it really easy is that a device, if you buy secure elements, you get a manifest, which is a proof of ownership that the secure elements are yours. And you can upload that manifest in our joint server, and that way you can claim your devices. Once you claim the devices, you can add parameters, you can say what the LoRaWAN versions are, things like that. And then you can print a QR code, or you can generate another security code or whatever that you give as a device maker that you give to the buyers of your device. And that way they can claim the device and they can activate it in their account. There is no transportation of security keys involved, and this works for all the devices all the device makers that we showed this morning on stage, even if they don't use a secure element. But this is how this claiming principle works. So this is also where the QR code app comes in. You don't have to use it. You can also enter the keys. You can use APIs, things like that. But we want to make it really easy, but yet still secure. So roaming and peering. It's my favorite topic. I've been talking about this for a few years. And so, like I said this morning, why would you exchange traffic? I think the reasons are pretty much clear. I think the most important reason is to increase battery life, because that makes LoRaWAN solutions very often more viable. And we also often get the questions, why won't you use LoRaWAN roaming? Because LoRaWAN roaming is designed for exchanging traffic, right? So we looked at LoRaWAN roaming, the specifications, and we don't really think that it's a good idea. If you want to know why, I'm not going to go into details, but you can Google LoRaWAN roaming. First hit on Google is my article. It's a few minutes read, and you can learn why LoRaWAN roaming is a bad idea. So I'm not going to go into details. The fact that this is the first hit in Google is also showing that it's not widely being used. So let's work on an alternative. So we have the packet broker, and also we are launching this after this week. It's a global backbone for LoRaWAN traffic, supporting uplink, downlink, device activations. It's open source, hosted, but also available on premises. If you have a big network yourself and you need to exchange traffic within your own network, come to us, we give you a packet broker, and you can do your own traffic exchange if you want. The key features are that you can, and this is, makes it different from LoRaWAN roaming, is that you can select which package you want to have. So if the device is in your own coverage area and you receive the message from your own gateways, why would you pay somebody else for routing that message to you? Because you already have it. So you want to have control over which packets you actually get, that you want to count in a transaction, and which one you don't. Second is that we separate the traffic routing from billing and peering. And in LoRaWAN roaming, that's also really tied in together. You have to have a contract, because when the contract is in place, the traffic starts flowing. Third is that we separate payload from metadata, because those are two different, they have different value. Maybe you already received the payload from your own gateways, but you want to have metadata for better localization, for example. Or you want to have both because you missed the payload and the metadata. And finally, you don't need to operate a LoRaWAN network. And I think Lacuna Space is a really good example because their assets and their company is all about launching satellites. They don't have to implement any LoRaWAN network or anything, roaming, whatever. They just forward the traffic to packet broker, and packet broker does everything else for you. So how does it work? Today, this is a standard cluster running the thing stack. Doesn't really matter. Your device sends a message, picked up by a few gateways, sent to a gateway server, ends up in the application server. That's how normal traffic flows. So let's focus on these two things, the gateway server, application, network server, sorry. The application server is still there, but it doesn't really matter for the rest of the presentation. What matters is that we add a packet broker agent, and that's a client component that runs in your network and that interacts with a packet broker. So packet broker agent will become part of the thing stack, open source as well. And if you have another network that also has packet broker agent, they can start exchanging traffic with each other. So how does it work? It can be either the things stack or the things enterprise stack. Since the APIs are open, we welcome other LoRaWAN network server vendors to look at the API and to see if they should implement it as well. It's fully open. We would be very happy to work with other LNS vendors and to see them join the packet broker initiative. Packet broker has a few components. It has a data plane, which is facing towards the network clusters. It has a router, and in between there we have PubSub. And in our current implementation, we use Kafka, but it could also be run in Google Cloud, or it could be using open source NOTs, for example. You can run it on premises. It doesn't really matter. It's a generic PubSub. And the way it works is that the packet broker agent can have two connections with the data plane. It can be a forwarder or it can be a home network. And a forwarder is when you are forwarding traffic from your gateways to the packet broker, and you are subscribing to downlink traffic. So you have your gateways, they receive data, you forward that to packet broker, and when some home network says, okay, I want to send a downlink message, it sends it back to the packet broker agent, and it forwards it to the packet forwarder on the gateway, and then it gets sent. The other role is home network, and that is when you have devices, and you can subscribe to uplink messages coming from other networks, coming from forwarders, and you can publish downlink messages. So we have four directions of two directions, but four sorts of traffic exchanges, actually. You can also be only a gateway server. If you only have gateways, you're just a forwarder. And these are the tower companies, or these are the Lacuna spaces that only have infrastructure, and they don't operate a network. But you can also have only network servers that don't own infrastructure, virtual networks that are not interested in deploying physical infrastructure, but they go to the packet broker and they see which other members to exchange traffic with, or you can do both. So how does it work? If the device is on another, seen by another gateway, traffic goes to gateway server says, okay, this message is not for my network, offloads it to packet broker agent, sends it to the data plane, picked up by the router, sent back to another data plane instance, and then sent to the home network. It's very simple. Routing policies. So you want to control, this is also unique to the packet broker, you want to control what home networks can see, because this depends on the arrangement that you have with them. And so you can say, as a forwarder network, so if you own a gateway, you can say per home network what data they may receive. So that could be join request, could be MAC layer payload, application layer payload, signal quality, localization. You can do anything. You can do only MAC payload, for example. You can pick and choose. And the same goes for downlink. And that means that you can open your gateways, for example, for sending join accepts and for MAC layer downlink. So your gateways will be able to send acknowledgements back to the devices or ADR instructions or things like that. But not application payload, because we have also customers that would like to open their gateways, but they would have a bad feeling with not knowing what the application payload is going to be that is sent from their gateways, which we completely understand. So we give that fine a level of control, and it's completely up to the forwarding network to decide what their gateways can be used for. So separating routing from clearing and billing means that we actually have another component in between. And all the traffic sent to and from packet broker is by default encrypted. So before a forwarder sends a message to the packet broker, it encrypts it with some encryption key. So the packet broker is not able to see what the traffic is about. And the packet broker just blindly routes it to the home network. And then it's still encrypted. So the home network receives an encrypted packet, and it needs to find a way to obtain the encryption key to decrypt the message. And this is completely free. So we don't impose any marketplace, any billing model. If you want to exchange keys via a postcard, you can do that. Routing is completely separate, and it's fully encrypted. So this is what a header looks like in the packet broker that's sent. It contains a teaser. So it doesn't contain the physical payload, but it describes what is in the message. So it says the device address, whether there are frame options, the frame counter, the frame port, frame payload length, if it's confirmed or not, and it has a hash of the physical payload. And with this, the home network can figure out in real time whether it has received this message with the same hash already on its own gateways. And if it didn't, it can find a way to decrypt this message And again, that's fully up to the arrangement that they have. We do have a key exchange, though. Again, it's optional. And a key exchange could be a balancer. So you could have two networks that are sending a lot of traffic to each other. And the balancer keeps track of the difference between how much traffic is sent from one network to the other. And maybe they want to only clear or have some small transaction on the difference if it's not fair. Or maybe they don't care about this at all. Maybe there is no encryption at all because it's not required. Or the two networks have their own way of exchanging the security keys. So this is how the packet broker works. Yeah, maybe it's not something that makes complete sense to you right now. I totally understand that, but it doesn't really matter. How to join the packet broker? Packet broker is fully LoRaWAN compliant, and that means that we route traffic based on LoRa Alliance net IDs. And so you have to have a net ID, and that means that you need to be a member of the LoRa Alliance, which is a little bit painful because it costs at least $3,000 per year, and that's the smallest net ID block that you can get. If you are a contributor or sponsor, it gets more expensive. But this is for larger private network operators like cities or larger companies that wouldn't be an issue. And you need to support a network server that supports Packet Broker. So that's the Things stack, the Things enterprise stack. We also exposed the passive roaming interfaces. You don't get all the nice features that the Packet Broker supports, but you can start exchanging traffic with the Packet Broker via the standard interfaces. And if you are using another network server, ask your vendor to implement the Packet Broker API, and hopefully they will do that. You also need to have a certificate, send an email, and you're done. You can start exchanging traffic. So, upgrading the Things network, community network, to the Things Stack v3. And actually, I can be really short about this, because we already have most of the gateways connected to our v3 gateway servers. So we've been replacing, in the last few weeks, the servers where the community network gateways are communicating with. Probably without you knowing. Maybe you've seen some packet loss because it was quite some maintenance. But this means that all community network traffic, not everything though, is already flowing through v3. And we offload it back to v2 at the moment. But this is for us a big step because we already have the data in the right place. And you can imagine that we want to continue high quality of service, even though it's a free service, even though you don't pay for it, but we don't want to have any day of downtime because of maintenance. So we did this gradually, and it was a big operation, and we're still not fully done with this. And the nice thing is also that the v3 gateway servers are already feeding data into Packet Broker. So this already works. And that means that we can actually see TTN traffic from v2, from all regions, from the 4 regions that we operate as a foundation, by the way. There are a few other regions in the Packet Broker. And these are steps that we take gradually, because we don't want to rush this. Again, uptime for us is more important than functionality. So we're going to work with the operators that operate other public regions to start upgrading their infrastructure as well to v3. But then still the devices are in v2, and you still have the v2 console and everything. So what we're going to do there is start deploying a v3 public community network, and it's going to run side by side with v2. So we migrate all the users, we migrate all the applications. We don't migrate any devices, but just the logins and the applications and the structure. And then you can log in to a v3 community network with all the coverage, all the gateways of the TTN v2 community network. And then you can choose to migrate your devices from v2 to v3. When you do that, there's no way back. So take care, do some testing. and adapt your APIs and your application to a new, slightly different payload format that we use in V3. We start with this in second quarter, so the plan is to have this ready side by side before the summer. And then we give you time to migrate to V2. We're not going to shut it down anytime soon. I think when I'm here next year, V2 is still up and running. But I would highly recommend you to start migrating. So that's it. That's my presentation. And do we have time for questions?
Yes, of course we have time for. But first, a very practical question.
Yeah.
I saw many people taking pictures of your slides, but they will be provided online, I assume.
Sure.
Yeah. When? And where?
I'll send them to the organization and see what they do with it.
And your timeline mentioned 2019, but that should be 2020, right? Yeah. Okay. So you can correct that and then put them online.
Yeah.
Okay.
Sure. Yeah.
Any questions? Yeah, over there. You're a bit hidden, so I do it.
Oh, thanks. Johan, about the LoRa packet broker. Who is the owner of the packet broker? Is that TTI Industries? And I was interested in the cost compensation models and how networks joining the packet broker are compensated for exchanging with others, and from private networks the other way around.
Yeah.
You comment on that?
Yeah, it's a very good question. So the few different pieces. Who owns the packet broker? So the packet broker is a hosted solution and a product. Currently, the routing component is not open source. We are still considering making that open source. It's not too complicated. The thing is, if we make it open source, we also have to support it and answer questions from the community, but it doesn't really matter. The hosted solution will be operated by us the same way as we operate the community network. So it's available, it's free. Community is not going to pay for anything. The other interesting topic, I think, which you asked, I'm not sure if that's exactly your question, but I also often get the question: so are you going to sell traffic from the community network? And obviously, we're not going to do that. So the way it works is that we require private networks to contribute back to the Things network if they want to exchange traffic with the community network. So what you saw on the slides in the beginning was 18,000 gateways that are globally in our ecosystem. More than half of that is community network, 10,500. And the rest is connected to our private networks. But ideally, everything is one big network. So that is what we start with. We interconnect all these networks, and it's going to be free for our customers, providing that they open up their gateways for the community as well. And it's not very different to what companies are already doing. There's a lot of commercial use on the Things network already. They set up gateways that are also accessible by community networks, and they make money on their solutions. So that's completely fine. Was there another question about it?
Yeah, okay. Do we have time for one final question?
Sure.
Okay, here you go.
Final question. Question is, will there be the possibility to run the packet broker on-premise, or is it something that is only available in the cloud?
It will be available on-premise as well. So it's a service and a product. And the way we designed it is that it's platform agnostic, and we support any pub/sub mechanism, which is actually the only dependency. So you can run this on Linux on premises with NATS or Kafka or in the cloud.